in the modern era where most application has to have a high processing with high TPS, Kafka become obvious choice for many applications. And today we will talk about Kafka from more of a system design perspective. Now, in that, let's understand what all things that we're going to cover today. We'll see first the need of Kafka and the entire gamut of partitioning. We'll understand from where consumer group came in and what problem they are solving, how consumer group ID is helping that. We'll understand a very essential concept of rebalancing and its working, what we should do and what we should not do to have rebalancing work in our favor, because this is a tricky concept which might go against us also. Then we will look into the best practices for partitioning, and at the end we will see a live demo of consumer rebalancing. You know, with that, let's understand the overall architecture of Kafka. We have a message producer who is pumping messages into a Kafka broker, which is sitting in the middle. Kafka broker stores messages in topic and it manages the entire ecosystem. And uh, now there are consumers who are subscribing to this Kafka topic and they get messages from the topic. Simple. We have producer, broker who is managing the topic of Kafka cluster, and there are consumers who is reading from this topic. This is the view from 100 feet above, right? But there are much more layers to this, which we will look into it when we will start looking into it in a microscopic view. Let's understand the use case, the need of it. We have a order processing system which is chewing messages 100 messages per second, but we have a sale coming up where the consumption is expected to go 10x, 100x, 1000x. Now the simple question over here, can a single consumer keep it up to this pace? Likely not. There are many problems with single consumer, right? There is processing bottleneck. Even if we will horizontally scale also, it will not be fruitful to a great extent. There is no parallelism and there is limited scalability. It After a certain point, single threaded consumers are meant to fail because of the processing bottleneck that they have. Now, what is this problem? What is the solution for this? And why Kafka came into, and what is the bigger problem Kafka is solving? Because similar concept existed before also, right? We have RabbitMQ, we have ActiveMQ, we have the messaging system, which is where there is a producer who is producing messages to a queue or a topic. Then there are consumers who are reading from that queue or topic. This is something which is public publishers and subscriber concept, which has been there from ages, right? So what is beautiful thing about Kafka, which is ensuring parallelism and which is by which we are achieving scale. The beauty lies in the concept of partition. Kafka have a concept called partitioning, which is the physical subdivision of a topic serving as a fundamental unit for data storage and parallel processing. Let's understand this few keywords over here. Subdivision of a topic serving as a fundamental unit of data storage. So a Kafka topic is a amalgamation of partitions. So Kafka topic will always have few partitions in it. right? In this case, order topic will have 0 to 3. Like there are 4 partitions. The partitions number start from 0 to 3. So there are 4 partitions, and it is the fundamental unit for data storage. So now this is where the data get stored. So topic will have partitions, and partition is the place where data will be stored, messages will be stored. And this is the key for parallel processing. Now there are multiple consumers who can who are reading from these partitions. That is where we are getting parallel processing. That is where we are getting scalability, right? The message which is meant for getting transmitted from system A or service A to service B, right? They are getting distributed. They are getting, it is no more a sequential message processing system, right? Or it is not a single threaded model, right? It is getting distributed with a number of partitions. So we have parallel processing, we have scalability, we have fault tolerance, where Kafka have concept right replication and rebalancing. By means of both of these, we are getting a good fault tolerance also. There is ordering within the partitions. So Kafka ensures that within the partitions, messages are preserved a order, right? This is something that Kafka ensures within the partitions, not across the partitions, right? Now, there is, while messages are landing into a topic, it is assigned a Kafka offset, a sequence which is ever increasing ID number assigned to each message as it arrives. As I was saying that whenever a Kafka messages lands in a partitions, it is given a sequence which is called a Kafka offset that acts like a bookmark for consumer, how much they have consumed. So that is the use of Kafka offset. We will look into Kafka offset in later video. Let's understand the concept only for now. That offset are a sequential number which is a ever increasing number which is assigned once the messages lands in a topic. Now let's revisit the same diagram that we saw in the beginning, where we have a Kafka producer, we have number of consumers, and now we are aware about the concept of partitions, which is the subdivision of topic, and partition is the one which is storing the data, and each messages have a offset, right? And Kafka broker is the one who is responsible for putting messages into the topic. So it is distributing, the Kafka broker is the one who is distributing the messages into the topic, and that is why that's how we are achieving parallel processing. Now, but there is a question over here. We saw that producer are pumping messages and the messages are getting distributed among the partitions. But how about consumer? Are they going to read all the partitions? Each consumer is allowed to read all the partitions? Wait, then there will be duplicate processing, there will be data inconsistency. Then are we going to have a problem with this? That is where, so obvious question, right? If there are 3 consumers, are they going to process all the messages? Answer is no. How the problem is solved? The problem is solved with the concept called group ID. Consumers within the same group are going to work as cohesive unit. The consumers within the same group will not compete with each other. They will work as cohesive unit. Consumers, so there could be multiple consumer group who could coexist. Consumers within the group will be assigned with partitions, And group ID is the one which uniquely identifies a consumer group. Without group ID, every consumer will receive every message, which we don't want, and that is why every consumer group is given a unique group ID. Now Kafka distribute partition among the group. Now we saw that we had order processing topic have got 4 partitions. So consumer A will get 0 and 1, B will have 2, C will have 3. There is no particular sequence for this. Kafka broker takes care of assigning the partitions to the consumers, but it maintains one significant rule over here. One partitions can be assigned to only one consumer within the group. From partition standpoint, it is always one-to-one mapping. Yes, a consumer can be owning multiple partitions or one partition, that depends on Kafka broker. But from one partition will be assigned to one consumer. Hope I am clear till now. Move now. So let's revisit the same diagram with a further microscopic view. Where we have consumer group order and consumer group audit, which is consuming from the same Kafka broker with the same Kafka cluster order topic. Consumer 1 have got partition is owning partition 1, consumer 2 0, consumer 3 we saw that it is owning partition 3 and 4, but in case of audit 3 is owning 0 and 3. As I told, there is no it is completely up to the Kafka broker to assign the ownership of the consumers, right? Now so far so good. Let's reframe this. What all we saw in with respect to consumer group. Consumer group could be running having different consumers within them, and consumer group will be consuming messages independently for each other. Within the consumer group, messages consumers work as a cohesive unit. There could be independent group who are consuming from the same topic, like order topic for business processing, for order management and all. There is a consumer group for analytical data, how a store is performing, how much orders are landing on a particular store, how much a particular SKU is getting sold for, all those things, analytical data about replenishment and all those things. We could reuse this. And for auditing also, like what time order got placed, what time order got invoiced, all those things we could use the same order topic also. Now each group will receive all the messages. They will maintain its own offset, right? Each group will maintain its own offset because they are consuming independently. That is why they will operate independently and maintain its own offset, right? Now let's look into the concept of partition assignment, right? How what could be the various cases, right? Let's look into it. Multiple cases over here. We have got a case where there are 4 partitions and 2 consumers. This will lead to a 4:2 mapping, right? 2 consumers will be assigned to 2 partitions. My bad. 2 partitions will be assigned to 1 consumer each, right? Now, in case of 4 partition and 4 consumer, when there is a 1-to-1 mapping, Kafka broker will map it 1-to-1, right? And this is the max we could reach. where we have one-to-one mapping. If we go further, where we have four partitions and six consumers, then there will be four active consumers who will be owning the partitions. The rest two will be idle. They will not be processing any messages. This is the starvation case where we could have consumers, but they are actually not doing anything. So we can optimally we can go to one mapping, right? We have one consumer who is owning a partitions. That's the max we can scale up to. That is where we have to have our number of partitions accordingly designed depending on how much consumers we have or how much consumers we could have. Now let's look into the concept of rebalancing. Rebalancing is the process of redistributing the partition among the consumers. Now, what are the need? The need could be new consumers joining, consumers leaving, and consumer crashing. And that one more beautiful concept, and runtime, we could increase the number of partitions also. That means we feel that the scale that we are operating, it could go up. That is why we should increase the number of partitions, which will trigger a rebalancing. We could add number of consumers for this typically to maintain a one-to-one ratio, or if we are not, then the new partitions will get redistributed. So consumers joins, new consumers joins. There were four partitions, two consumers, one came in. So now 4:3 mapping is there. So that's where rebalancing will take place. There were uh, 4:3 mapping. Uh, one leaves. Now we have 4:2 mapping. Same. So consumer leaving is where we want to scale down. Consumer crashing is consume for due to some error, or more than error, consumer for some Kafka config internal thing that we will look into it. Kafka broker saw that this consumer is not responding, and that is why it will mark that consumer as dead, and that is why it will ignore that consumer. Now that's where also it will trigger a rebalancing. Now goal is to maintain a workload across consumer. That's the goal over here. Let's relook into this. Now we have the load which is there for us, and now few consumers have joined, few consumers are dead. We are increasing the partitions. Now load has to be redistributed. That is why rebalancing is taking place, right? But let's understand these rebalancing events, and then I will tell you why this rebalancing is a double-edged sword. It could act in favor of us, but it could act against us also. So now Kafka rebalancing steps. First change occur in the consumer. Consumer joins, consumer leaves. We saw that change has occurred. Now there is a group coordinator. In the Spring Boot application, we will see the log. A group coordinator will be notified for the change. The group coordinator instruct consumer to revoke their current partition ownership. This is where it is the partition ownership will be revoked, and that's where consumption will halt. That means there will no consumer who will be reading messages from Kafka topic. That's where Kafka messages lag means the of messages which have not been read from Kafka topic will start piling up since there is no consumer reading, right? So it could lead a lag, the message lag could go on increasing because your rebalancing has stopped all the consumer. Now, typically it happens for a brief period, but if things are not in shape, then it could go longer. So that is why we have to be careful. This new assignments calculate the new partition assigned using the algorithms range or route probing, multiple algorithms Kafka broker could use, and the new assignments are sent to the consumer and acknowledged. The new partition assignment will be sent to a particular consumer and the consumer will acknowledge also. After that, consumption will start smoothly. Now, key takeaway, rebalancing ensure that partitions are evenly distributed among active consumers for optimal parallel processing and high throughput. So optimal parallel processing and high throughput. That is why rebalancing is taking place, as we saw. Now there are few configs which will tell Kafka broker that the state of the consumer. First is the heartbeat. First is the heartbeat, right? Where every the default is 3 seconds. Every defined interval there is a heartbeat going from consumer to Kafka broker saying that I'm alive, I'm alive. Now second is session timeout. Maximum time the broker allows a consumer to go without sending a heartbeat. If it misses this, the broker assume consumer crashes and trigger a rebalancing. Now this is what I was talking about. If it misses for let's say heartbeat for session timeout, whatever we have set, we Kafka broker have not got a heartbeat from a consumer, then it will think that the consumer has gone dead, and that is where we saw the case of consumer crash, and then it will start rebalancing, right? And that's where again for brief time consumption is going to stop. Now another scenario, Kafka will poll for Kafka consumer will poll Kafka broker periodically to get messages. Now maximum time broker allows between the consecutive polls, right? That's the max poll interval. Now if consumer takes longer than this to process message, broker will kick it out from the group, could trigger rebalancing. Now let's say there are got 5 minutes it has got. Within that, if it is not able to process all this data, then it will miss the heartbeat and will think that this guy is dead and I should rebalance. Max poll records. What is the maximum poll while the poll is polling, while the consumer is polling? What is the maximum number of record one should get? The consumer should get. If you have a consumer who is processing is slow, then this should be little low, else by default it is 500. We can alter it which will act to in our favor, which will not trigger periodic rebalancing, because as we saw rebalancing could be very expensive, where consumption could stop and then Kafka topic lag will start mounting, which is what we don't want, right? Now few production recommendations. We should have partitions greater than equal to number of consumers. We saw that. We should plan for future growth. right? We should have good amount of partitions to consumer ratio so that our consumption are optimum. That's what we mean by plan for future growth. Monitor the consumer lag, the number of unprocessed message in Kafka topic. We should always have an eye on the consumer lag. If there is consumer lag, then we have to take few steps, which like either increase the number of consumer or increase the number of partition if one-to-one mapping is already achieved, something like that, or optimize our consumers to have their processing time better, stuff like that. This is very crucial. Use cooperative sticky balancing. By default, older Kafka client uses eager rebalancing protocol, which is like stop everything and rebalance. But the cooperative sticky asyntor uses an incremental protocol that will say that only specific partitions need a change hand, allowing unaffected consumer to continue. So consumption will not halt. Only few partitions whose consumers are having problem, their reassignment will take place, where consumption will not stop. As I have been telling, avoid excessive rebalancing and keep processing time below max pole interval. You know, these are the things that we should keep in mind for a production system. Now let's jump into the demo, where we will see a live rebalancing in a Spring Boot application.